Hello everyone, my name is Mehmet Akif and I'm gonna present Turing architecture and ray tracing. What is Turing architecture? Turing is the code name for a graphic processing unit, microarchitecture developed by NVIDIA. Turing architecture introduced the first consumer products capable of real-time ray tracing, a long-standing goal of the computer graphic industry. Key elements include dedicated artificial intelligence processors and dedicated ray tracing processors. Turing represents the biggest architectural leap forward in over a decade, providing a new core GPU architecture that enables major advances in efficiency and performance for PC gaming, professional graphic applications, and deep learning inferencing. Using a new hardware-based accelerators and a hybrid rendering approach, Turing fuses rasterization, real-time ray tracing, artificial intelligence, and simulations to enable incredible realism in PC games, amazing new effects powered by neural networks, cinematic quality interactive experience, and fluid interactivity when creating or navigating complex 3D models. NVIDIA Turing is the world's most advanced CPU architecture. Turing microarchitecture combines multiple types of specialized processor core and enables an implementation of limited real-time ray tracing. Turing GPU has three different types of processor core. First one is Turing streaming multiprocessors. Streaming multiprocessors that delivers a dramatic boost in shading efficiency, achieving 50% improvement in delivered performance per CUDA core compared to the Pascal generations. Second one is tensor cores. Simply Turing tensor cores accelerate the matrix-matrix multiplication at the heart of neural network, training and inferencing functions. Third one, and the most important one, is RT cores. RT cores accelerate bounding volume hierarchy (BVH), traversal and ray triangle intersection testing functions. To better understand the functions of RT cores and what exactly they accelerate, we should first explain how ray tracing is performed on GPUs or CPUs without a dedicated hardware ray tracing engine. Essentially, the process of BVH traversal would need to be performed by shader comp operations and take thousands of instruction slots per raycast to test against bounding box intersections in the BVH until finally hitting a triangle end. The color at the point of intersection contributes the final pixel color. So, what is ray tracing? Ray tracing, which has long been used for non-real-time rendering, provides realistic lighting by simulating the physical behavior of light. Ray tracing calculates the color of pixels by tracing the path that would it take if it were to travel from the eye of the viewer through the virtual 3D scene. As it traverses the scene, the light may reflect from one object to another, causing reflections, be blocked by an object, causing shadows, or pass through transparent or semi-transparent object, causing reflections. All of these interactions are combined to produce the final color of pixel that then displayed on the screen. There's an example here to understand ray tracing better. In this picture, light is coming in from the window. It's bouncing all over the room. The vast majority of this room is being illuminated indirectly. Whenever light touches a material, that material is rendered and simulated physically. The material is metallic or dielectric, is either smooth or rough. The colors can be glossy or matte. At the end, the entire room looks alive. When the light bouncing around this entire room, it doesn't strike every surface the same way. Some of it occluded from light, we call it ambient occlusion. You also see there is a desk lamp and shining through the glass. And because the glass has curvature in shape, light refracts around it and accumulates in a way. As you can see in this picture, she is reflected in a mirror. even the parts that you don't see. You know how mirror works. You could see behind things, but we can't see that mirror reflection features in video games. All those little tiny effects are really hard to do, so ray tracing handle with it. There's a video about how ray tracing works in games. Please watch carefully and see how reflections change. Thanks for listening. Stay healthy and stay home.